I don't know.
So in Greek, the letter gamma can represent a C or a G.
Oh, C. All right. When you are doing an absolute value bar, inside the absolute value, remember negatives become positives and positives stay positives. So when I'm looking for absolute value of something equaling 6, inside here, that can either equal 6 or a negative 6. Because negatives, absolute value of negative 6 would still equal 6, and a positive 6 would equal 6. So if x plus 2 equaled 6, it would work. If x plus 2 equaled a negative 6, that would also work. So when you have absolute value bars, you break it apart into two possibilities. The inside equals the negative version, or x plus 2 equals a positive 6, and then you just solve it. So we subtract 2 from both sides, so we're going to have x equals negative 8. In fact, there's only one up here that's a negative 8, so it must have been C. And then we subtract 2 from both sides, and we'll have x equals 4. So we have x equals 4 and x equals negative 8. For the next one, you shouldn't have done much work, because if you divided both sides by a negative 3, you'd see that 3x plus 2 has to equal a negative 3. That's impossible. That is impossible. An absolute value can never equal the negative number, so this one is no solutions. It's pretty tricky. Okay, questions from the homework. Jacob. Yeah. All right, so we have two equations hooked up by an AND symbol. AND means that it has to be in both. It is that intersection. Where is their overlap? So we need to first solve both sides of the equation. So we had 1 minus 3 over 2x is less than 4. And we also have 1 over 4x minus 2 is less than or equal to negative 3. So one thing you could do is you could go ahead and get rid of the fractions if you wanted to. So you could have multiplied this one by 2, distributing that 2 to everything, which would lead us to the equation, bless you, 2 minus 3x is less than 8. And I'd multiply the other one by 4 to get rid of that fraction. So we'd have x minus 4 times 2, which would be 8, is less than or equal to 4 times a negative 3, which would be a negative 12. Now let's go ahead and continue solving it. Subtract 2 from both sides from that 2 minus 3x. That will give me negative 3x is less than 6. Now I have to divide by a negative number. I am dividing by a negative 3, which means I need to flip that symbol. So we are going to have x is greater than, so once again I am dividing by a negative 3, so that means I need to flip that symbol, which means x needs to be greater than a negative 2. This one I just need to add 8 to both sides. We'll have x is less than or equal to a negative 4. So we have x needs to be greater than negative 2 and x needs to be less than negative 4. Can you name any numbers that are greater than negative 2 and are also less than negative 4? No. So there's going to be no solutions. There's going to be no solutions. If I graph this, you'd see we'd have one graph going in that direction, one graph going in that direction, and there'll be no overlap. And is, when does it overlap? And means it has to work in both situations. It has to be greater than negative 2, and it has to be less than negative 4, which does not work. So that one has no solutions. Safa.
With 45,
Mm-hmm.
0 is less than 2 minus 1. Why don't you flip the sign?
What did I do there? I did flip the sign.
Oh.
So when I solved it, so let's look at the picture. I mean, I flipped it in my own little way. In my own little way. I didn't leave x on the same side, if it ever appears. I didn't leave x. So if I would have subtracted 7 from both sides, I'd have negative 7 is less than negative x. And if I divided both sides by a negative, I'd flip the sign, and we would have 7 is greater than x. Well, I put the x on this side saying x is less than 7. You would have came out, so if you actually solved this as is, you would have came up with 7 is greater than x with the flipping of the, see how the sign actually flipped? I always write the x on the left-hand side. It makes it a little easier for me to picture what's happening. Because sometimes when I say 7 is greater than x, people really struggle with what that means. But if you flip the other way and say x is less than 7, it makes a lot more sense. Mary?
Can you still keep going through this one again? Because I was kind of confused how we got it so much. Because I have like the x is greater than 5 but less than 7.
Okay.
Like, why is it negative infinity to infinity?
So we could do either one of these. X can be greater than 5, or it could be less than 7. So it is both sets combined. So if you think of the set of 5, x being greater than 5, that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way up here. X being less than 7 is 7, 6, 5, 4, 3, 2, 1. So when you combine both of them, it's going to be negative infinity to infinity because it doesn't have to go in both. It's just either this one or this one. If you do the graph, you'd see that combine them together, you'd shade in the entire number line.
Okay. Thank you.
In fact, with these or statements, sometimes it's nice to just make one number line, Mary. And since it's an or statement, I would go, okay, greater than 5. If I had 5 here, I'd shade in that section. Less than 7. 7 would be over here, maybe. Less than 7, you're going to see, okay, the overlaps everything, so it would just be the entire number line, negative infinity to infinity. Nicholas? 37 asks us to do the union of negative infinity to 4, and we're supposed to union that with 4 to 5. Now, note, union means I'm combining the two things together. I'm adding together, correct? So, if we look at the graph of it, if we look at the graph of negative infinity to 4, let's go ahead and do a quick number line. We'd have a 4 here, and then we go all the way up here. Now, we are adding in 4 to 5. So this would be my 4. Let's actually do a number line. And then we actually include 5 in that guy as well. Now, we are adding those two things together. That's what union means. It means add the two things together. So if you picture this moving up here, 4 would now be included in it. So 4 is not included up here. But when I add this in, we are going to now include 4. So if you picture this, now this becomes a bracket all the way to bracket 5. Well, this is negative infinity all the way to 5 because now we include 4. There's no gaps between them. So the correct answer would be negative infinity to 5 with a bracket around 5 because it does include 5. Okay?
And then also for like,
Whoa, how do you get 2 questions?
for the questions with the graphs, how do you use the graphs? Like, what are they for?
Can you give me a specific?
25.
25, solve the inequality by reading the following graphs. Oh, I see what I mean. So it says, when is 2x minus 3 greater than 5? This is actually what inequalities are. At the heart of it, this is what's happening. So it's asking you, so it gives you 2 graphs. It gives you 2x minus 3. And it asks you, when is this greater than 5? Well, this is my x value, so this must be my y value. They're saying, when is it greater than when y equals 5? So if I draw the line of where y equals 5, this graph, 2x minus 3, will be greater than 5 any place where above that line. If I would put, when is this less than 5, I would have circled this area because it's below 5. Less than means below. That value is less than. And Nicholas, what makes more sense, I guess, is what I'm saying is if I plug in 5 into this equation, I'm going to get out that value, right? That value is bigger than 5. right? When I plug in 5 here, I'd have 10 minus 3, which is 7. Well, if you look at the graph, 5 equals 7. These are all the values where it would be bigger than 5. These will be all the values where it's less than 5. Right here, these are going to be all the values less than, it must be, 2 equations. So I'm looking at when is this one below this line, which would be right here. Because it specifically says x plus 1 is less than that line. When is it lower than that line? And this would be the more negative direction.
Okay.
Safa.
Why did you circle the top half?
Because it says when is it greater than or equal to 0. So you're trying to figure out when is that line above y equals 0. So I circled everything on the top half because that's everything that is. So like I said, we have 6.3 minus 4.5x is greater than when y equals 0. So y equals 0 is this line on the x-axis. So anything above this line is going to be above 0, including this point right here, because it says it does include 0 in it. So that's going to go from x values negative infinity all the way to when x is 1.4.
But if the equality says x is less than or equal to 1.4. Then why don't you circle the bottom part?
Because those aren't x values, those are y values. My x values are these values here. Those are my x values. So x goes from negative infinity. If I'm looking at x values, it goes negative infinity, negative 3, negative 2, negative 1, 0, 1, 1.4 works. 2 doesn't work when I plug it in. 3 doesn't work. 4 doesn't work because 4 would end up down here. So that's why I have x needs to be less than or equal, or in other words, from negative infinity to 1.4. So if I plug in negative 2, it will work because it's going to be way up here. If I plug in 1, it will work because that value is a positive value. When it's going to stop working is anything bigger than 1.4. So x has to be from here left. Those are the only values that work. Does that make a little more sense? You sure? Okay. Let me know if you're still confused on it. Other questions?
No.
Okay. Then we'll go over to today's lesson. Today's lesson really only has a couple key concepts on it. The big one is absolute values with inequality signs. Well, just like if I have an equal to sign, you need to split up inequalities with a negative and a positive version of itself. So if we go back to our bell work, we split it up into x plus 2 equals negative 6, and x plus 2 is equal to 6. We're going to do the exact same thing, except for the inequality is going to change a little bit. Let's do the or statement first, and then we'll talk about this one. Whenever you have an absolute value is greater than a number, you're going to split it up into two equations. You're going to split it up into 1 minus 2x, something with positive 9, and 1 minus 2x, something with negative 9. And we're going to put an or between the two. Now, 1 minus 2x, we're going to keep the exact same sign. So when you do 1 minus 2x, you're going to keep whatever sign is there. I'm not altering anything. Remember, the big thing that flips sign is multiplying by a negative number. Well, if you look at the other side, I now need to multiply basically that 9 by a negative 1. So in that case, you need to flip the sign because you are flipping that sign. You are flipping the sign to negative, so you need to flip your sign that was given to you. It's just like multiplying by a negative number. Whenever you have a negative number, you flip it. So the positive version, you just leave the sign. So if you're not changing this sign, you're going to leave this alone. If you ever change the sign on the right-hand side, then you need to change your sign as well. And then you're going to put an or statement between it. So greater than is an or statement. Once again, greater than is an or statement. It's either in this one or it's in this one. So if we keep going down and solve both sides, we'll see that x is less than negative 4 or x is bigger than 4. If you think about that graph, let's just do it on the side really quick. There's a reason why these need to be or statements. And that is because if I graph this, we're looking for where x is less than negative 4. And we're looking for where x is greater than 4. That has to be an or statement, otherwise you'd have no solutions. Mark?
Wouldn't negative 9 minus 1 be negative 10, not negative 8? On the right side, middle one?
You are 100% right. That has never been caught. That is a great... I'm going to give you a point for that one. So yeah, that would be negative 1 and negative 1. This should have been a negative 10. And that would have made this 5. So rather than that being a 4, that should have been a 5. Yeah, 100%. I'm going to write that down. Mark, you should get... Good catch, yeah. The premise stays the same, though. Still has to be or. It just changed that one value on the other side. All right, now look at the less than symbol. The less than symbol turns into one statement. It turns into negative 9 is less than 1 minus 2x is less than 9. Now, the reason why I wanted to do this one second is because these two problems are almost the exact same, except this is an and statement, and this is an or statement. Less than symbol is an and statement. It is that overlap between the two. And I'm going to prove that to you right now that they both are the exact same. If you look at that, negative 9 is less than 1 minus 2x is less than 9. It's just an easy way to say this. This is the exact same thing as 1 minus 2x is less than 9. And 1 minus 2x is greater than negative 9. Notice this is the exact same statement as this, just with an and statement between it. But because there's an and statement between it, I can write it as one statement. That negative 9 is less than 1 minus 2x, and 1 minus 2x is less than 9. So when you have a less than statement, you can do it this way. This way is just a little bit easier to set up. Once again, you can do it this way. This way is just a little easier to set up. Note, whatever way your sign is going, that is going to be the direction you'd write it between the two things. All right, then just like we did yesterday, we'd subtract 1 from both sides, which gives us our negative 10. It gives us our 8. Then we divide both sides by negative 2. Note both of my signs change because I'm dividing by a negative 2. And we have 5 is greater than x is greater than negative 4. The graph of that would look something like this. We'd have negative 4. We'd go to 5. And we'd shade that area in. So an or statement are our two ends. The and statement is the numbers between that negative 4 and 5. All right, so real quick. Greater than is an or statement. Less than is an and statement. All right, let's go through some problems. All right, the first one is pretty easy. That is a less than symbol. Just remember, a less than symbol is our and statement. So there's two ways we can write this. We can either write this as x is less than 3 and x is greater than negative 3. Or we can simply write it as one set of inequalities. So that'd be negative 3 is less than x is less than 3. Note in either case we get the same graph, and I wouldn't have to do any more work. There's no actual solving for this one. So if I was to graph this one, we'd have from negative 3 to 3, and we'd have something like that. In interval notation, that would be negative 3 to 3 using parentheses, because it's not including those. A less than equation will almost always look like this. In fact, I'll go on a limb and say it just always looks like this, especially in this class. A less than symbol will give you this thing that goes across like this. All right, x, absolute value of x needs to be greater than 5. Greater than is an or statement. So we're going to go with x is greater than 5, or x is less than negative 5. Note, when I do the negative 5, I flip the sign. There is no way to combine an or statement. Only and statements can be put together. So like I said, there's nothing we can solve from this one. We're just going to go ahead and graph it. So we're going to have x is greater than 5, so we have 5. We'll draw some lines over there. X is less than 5, so we'll do a parenthesis at negative 5. And we'll shade in the line right there. In interval notation, that would be negative infinity to negative 5 parenthesis, union with 5 to infinity. These are going to be your greater than graphs. They'll be either side of your points that you're coming up with. Our next one's weird. Why is it weird? Yeah, Priya. It's a negative number. Can an absolute value ever equal a negative number?
No. But it can be greater than that.
But it can be greater than. So let's think about the possibilities of this. Can absolute value of 3x plus 2 equal negative 7? No. Can it equal negative 6?
Oh.
No. Negative 5?
No.
Negative 4?
No.
Negative 3?
No.
Negative 2?
No.
Negative 1?
No.
Negative 2?
No. No.
0?
Yes.
It can equal 0. So the first one that's possible is actually 0. So I'm actually not asking you when is 3x plus 2 greater than negative 7, because several of those don't work. Only 0 and up work. So that means negative 7 through negative 1 will not work. So that leads us to changing this to being absolute value of 3x plus 2 needs to be greater than, what about equal to? Would equal to 0 work in this problem?
No.
Is 0 greater than negative 7?
Yes.
So would I put an equal to sign there?
No.
Yes.
I absolutely would. I would absolutely put a greater than or equal to 0. Because 0 works, and 0 is bigger than negative 7. So realistically, this question is saying, most of these values, the beginning values don't work. These are the first values that will work for this problem. This will be the first values that work. 0 is the first value that works. So I just had to change a little bit. Now we have a greater than sign. A greater than sign is an or statement. So we are going to have 3x plus 2. Since we have a greater than or equal to, we're going to say greater than or equal to 0.
It should be plus 2, right?
Oh, yeah. Or 3x plus 2 is less than or equal to 0. What's going to happen when I graph this, though? Yeah.
Isn't it just gonna be 1 point?
It's gonna be the whole line.
It's going to be the whole line. Why is it going to be the whole line?
Because 0.
When is an absolute value bigger than 0? Or when is an absolute value bigger than negative 7? When is an absolute value number bigger than 0? What was that? Always. So we actually don't have to, we're going to finish this problem, but we don't actually have to do all this work. So we subtract 2 from both sides and then divide by 2, and we'll see that x needs to be bigger than or equal to negative 2 over 3. On this one, we'd say x has to be bigger than or equal to, or less than or equal to negative 2 over 3. This would be the whole number line. So let's look at what we have here. So we have x needs to be bigger than or equal to negative 2 over 3, but it also can be less than or equal to. So we basically have 2 brackets there. Bracket means I include that negative 2 over 3, and then overlap means it includes everything on the number line.
Oh, gotcha.
But holistically, you don't have to do any of this work. You can stop right here and say, Mr. Padian, an absolute value is always either 0 or positive. 0 or positive is always going to be bigger than a negative number. So an absolute value of anything that's bigger than a negative number will always be infinite solutions. So if this was 3x plus 2 is greater than negative 6, all solutions. If this was absolute value of x squared plus square root of x plus 36 is greater than a negative 1, it's going to be all solutions. You don't have to do this work as long as you understand what absolute value means. Absolute value can only be 0 or positive. So if I'm telling you that this absolute value is bigger than some negative, you're going to say it's always bigger than negative. In fact, we can go to the stage that I say, if this was 3x plus 2 absolute value being greater than or equal to 0, that would also be all solutions. Until you start getting bigger than that, do we have to start doing stuff? Yeah?
So if it's less than a negative, then it's no solution?
It would be no solutions. If I flip this sign and say, when is this absolute value less than negative 7? You'd say there's no solutions. An absolute value can never be less than a negative. It can't be less than 0. So whenever you have a negative on this side, if it's all by itself, if you have an absolute value bar and a negative over here, you're either going to have all solutions or no solutions. You just got to figure out which one it is. Or you can do all this work, get your answer, and waste a couple minutes. Yes?
What if it was an absolute value less than or equal to 0? 'Cause if it
Then you'd have one place it would work, where it equals 0.
Okay.
So you'd set it equal to 0, figure out where that works, and that's the only place it's going to work. On our next one, it has that negative on the right-hand side. Does that mean I'm going to say that it's no solutions? No, I'm not, because it's not an absolute value bar all by itself. It has that negative 2 in front of it. So you need to have that absolute value alone before you can do that negative property. So the first thing you're going to do is you're going to divide both sides by a negative. What do we do if I divide by a negative? You flip the sign. So it's going to be greater than or equal to 2. Greater than or equal to 2 means it's an or statement. So we're going to have 4 minus x is greater than or equal to 2. Or 4 minus x is less than or equal to 2. Subtract 4 on both sides. We'll have negative x is greater than or equal to negative 2. Divide both sides by negative 1. We're going to flip our sign and have x is less than or equal to 2. On the other one, we should actually have this being 4 minus x is less than or equal to a negative 2. I forgot to flip that sign. So when I subtract 4 from both sides, we'll have negative x is less than or equal to a negative 6. Divide both sides by a negative, and we're going to have x is greater than or equal to a 6. Now with an or statement, I should have arrows going in both directions when I shade them in. X is less than or equal to 2. So at 2, I'd put a bracket, and I would shade everything less than it. At 6, I'd put a bracket. I would shade everything greater. Our interval notation, I didn't really leave much room for me, but I'd have negative infinity to 2, including 2 with a bracket. And we'd union that with a bracket 6 to infinity. That is every less or greater than problem. It's going to end up with both directions, and you're going to have a union when you put it in interval notation. Less than symbol, it can be between 2 points. Greater than, you're going to go in both directions. That's how you generally know if you did it right or wrong. All right, continuing on. Application problem. It says a student received a 74 on the midterm exam. To get a B, the average of her midterm exam and final exam must be between 80 and 89 inclusively. We're going to assume that the final and the midterm have the same weight. What range of possible scores on the final would give the student a B in the course? So first of all, we're taking a midterm exam. We already have that score. And we're going to take a final exam. I want the average to be between 80 and 90 inclusive. That means it includes 80 and it includes 89. So inclusive tells you you're going to use a less than or equal to or a greater than or equal to sign. All right, so my low end needs to be an 80. So we're going to put something in between here and 89. How do I come up with the average of 2 tests? Okay. Add them together and divide by 2. I know what one of my tests are. That's a 74. I don't know what the final is going to be, so that's going to be plus x. That x is going to be your final score. And we're just going to divide by 2. All right, so we'd multiply everything by 2, and we'd get 160 is less than or equal to 74, plus x is less than or equal to 180 minus 2 would be 178. And then we're going to subtract 74 from both sides. That's going to be 100 minus 14, so that's going to be an 86. Is less than or equal to x, which is less than or equal to, yikes, 104. You can get an 86 on a final, can't you?
Well, you got a 74 on the midterms.
That's true, that's true. Maybe she really worked at it. Does 104 make sense on a final?
Yeah.
It could, depending on a class. Some classes offer extra credit. A more realistic answer would be 86 to 100. Or strictly just saying, I need to get better than an 86. In this class, this is fine. But in the real world, you just go, oh, I just need better than an 86. I don't think many people are going, I need to be between an 86 and a 104. I think you're just thinking I need better than 86. So an actual answer to this problem would probably be I need an 86 or greater. Because an 86 would work, or anything greater. This is fine for like a test, but just real world, you just say I need an 86 or better on that. All right, the last thing we're going to talk about is absolute error and relative error. This can be on the test. I would just give you the equations for it. All right, but it can be on the test. Absolute error. If L is an actual length and X is the length determined by a measurement, then your absolute error will be X minus L. Take the absolute value. What absolute error is say I'm building a part and I want it to be 13 feet long and I accidentally cut one that's 14 feet long. My absolute error would be 1 foot. It is 1 foot too long. Or if I'd cut it 1 foot too short, it would still be my absolute error being 1 foot. Relative error, on the other hand, will be the percent too big. Maybe that 1 foot is 10% bigger than I want my error to be. So these will be a percent. This will be an actual 1 foot too big, 1 inch too big, 1 inch too small. This will be a percent compared to how much error you are allowing. Yes?
If it's like too short or something, why don't you say a negative?
Because I don't care that it's a negative.
Okay.
I only care that it's off.
Okay.
And a lot of machining shops, so if you go to a machine shop, they don't make every part the exact same. Kind of like when you buy a bag of chips and it says there's 12 ounces of chips in there. There are not 12 ounces of chips in there because potatoes don't grow like that. So they have an error on either side. They just say it can be 1 ounce in either direction. That's way too big. But they'll have a relative error that they're allowed to put in. That relative error would be like 0.6%. They don't care if it's too much or too little. They just care it's within this margin.
So like when they say like plus or minus.
Yeah, you can actually say relative error is 1 ounce. You don't have to say plus or minus. You can just say relative. They say plus or minus because people don't understand what absolute and relative error terms mean. But now we do. All right, my problem is a technician is testing a scale with a 50-pound block of steel. The scale passes this test if the relative error. So relative error tells me I'm going to use this equation. That means I'm dealing with the percent. And you'll see when weighing this block is less than 0.1%. So my relative error needs to be less than 0.1%. If x is the reading on the scale, then for what values of x does the scale pass this test? Now let's talk about what L is. L is the actual length, weight, temp, etc. And x is determined by this measurement. So L is that weight that we want. It is that 12 foot I want to cut. In this case, our L is going to be that 50 pounds. So L is going to be what I actually want. I want it to be 50 pounds. When I weigh these, we're weighing a 50-pound block, and this scale should be about 50 pounds. If it's too big, I got to throw out the scale. If it's weighing it too little, I'm going to throw out the scale. So our x is going to be what our scale actually pumps out. So according to that formula, if I do x minus L, which is 50, take the absolute value and divide by 50, it says that that relative error needs to be strictly less than 0.1%. So we can't really put percents in, so we have to put a 0.001 because we need to move that decimal place 2 points. That's 0.1%. All right, real quick, we're going to multiply both sides by 50 to get the absolute value bars by itself. So we'll have x minus 50 absolute value is going to be less than 0.050 or just 0.05. All right, a less than symbol is an and symbol. It's the one we could turn into two equations. So we're going to turn this into a negative 0.05 needs to be less than x minus 50 needs to be less than 0.05. Excuse me. Now we just need to add 50 to both sides. So on this side, we're going to have 49.95 is less than x is less than 50.05. So when I weigh a 50-pound block on this scale, in order for the scale to work, it has to measure somewhere between 49.95 and 50.05. And it can't include 49.5 or 50.05. That is relative and absolute error. On the test, I'd most likely just use relative error if I was going to put one on there. But like I said, if I put it on there, I will put the equation on there as well. All right. Have a wonderful, wonderful Thursday. We're done.